let's take a look at what's involved in creating a linear function from information that you might be given. In the last video, we saw one situation that we might have. We might be told the unit cost. Let's say, as in the example we looked at before, the unit cost is $35 per anvil. And the fixed costs are $2,500 per day. Well, this unit cost is really our slope. That's our m value in our equation y equals mx plus b. And the $2,500 per day is our b value. That's the y-intercept. So in that situation, we were given the slope and the y-intercept immediately. So we can easily write our equation or our function, our cost function, if we want to use the function notation. So sometimes we are given the slope and the y-intercept, and we can quite quickly find the linear function that relates cost to number of items produced, in this case, the anvils. Well, let's suppose we weren't given quite that much information. Let's suppose that we were told that the unit cost of making our anvils, unit cost for an anvil was that $35. And then we were told, so we were given the slope, weren't we? This is dollars per anvil. And if we want to write a cost function where the cost depends upon the number of anvils, that would be our slope, wouldn't it? The y is cost, the x is anvils. Cost per anvil would be change of y over change of x. That's what we have here, cost per anvil, $35 per anvil. So in effect, we were given the slope. But then someone said, one day when we made 10 anvils, the cost of making those 10 anvils was $2,850. In effect, what we were given is a point. If we are relating cost and anvils, and the number of anvils is like the x value, and the cost is the y value, then having 10 anvils that cost us $2,850 to produce, that's as if we were given a point on the line. If this is a linear relationship, there's a straight line. So we've actually been given the slope and a point. And so we can use that information to create our equation. And remember, our equation is a linear equation, so it's going to have this form, y equals mx plus b. Well, if the $35 per anvil is my slope, then my equation so far, from the information I've been given, my equation so far looks like this, y equals 35x plus b. $35 per anvil. X represents the number of anvils. Y represents the cost. Or I can use my function notation. Cost depends upon x, depends upon the number of anvils we're going to make. Now, how do I use this point to figure out the b value to finish off my equation? Well, if this is a point, again, these are x, y values. So what I can do is I can take this y value of 2850 and put it in place of y here. I can take the x value of 10, put it here, And that produces an equation that only has b that I can now solve. 2850 equals 350 plus b. Subtracting 350 from both sides, I get b equals 2500. And I can now use that value for b, that value of 2500. And I've produced my cost equation, my cost function, where the cost depends on the number of anvils we're going to make. Y, or C of x, represents the cost. X represents the number of anvils we're going to make. And the cost is dependent upon the number of anvils. $35 per anvil plus $2,500 in fixed costs. So in this instance, I was able to find that cost function because I was given the slope and a point. The point was telling me how many anvils were made and what was the total cost. So I was able to use that information along with that unit cost, which is my slope of my line, to produce my cost function. So sometimes we can find the cost function, the cost equation, when we are given the slope and the y-intercept directly, or if we are given a slope and a point. And there's one more situation that we often encounter that we use to find the cost equation, and that we'll cover in the next video.